before G, we need to put the function in the correct format before we graph using transformations. I need to factor the inside of my function so that there is no direct number next to the x where it's not directly multiplying by the x. And the way that we do that is we're going to factor out the 2. So my function on the inside now will have a 2 factored out of the 2x minus 4, and then I'm left with x minus 2. And now we are in the correct format on the inside to use transformations. And the easy transformation that I see here is the minus 2 in x minus 2. That number that's being subtracted on the inside is going to cause a left-right shift, and it's opposite of what you think it should be. X minus 2 is actually going to move your graph 2 units to the right. And the other transformations that are going on are a little more difficult and challenging to do, especially when they're all happening at once. So we're just going to talk about those one at a time. The first thing that I want to talk about is this 2 that is on the inside of the function. That 2 is actually going to change your horizontal movement, and it's going to either stretch or compress it. And that would be taken off the x values if you were doing an xy table. We'd be looking at the x values. The number on the outside of the function affects your vertical movement. It's either going to vertically compress or stretch your function, and that is going to affect the y values in your xy table. And let's go ahead and actually write down the xy table for the parent function, and the parent function is going to be x cubed. Take away all those little extra numbers on the inside here of the 1/4, the 2, the other 2 over here, and you are left with x cubed. So our parent function is f of x equals x cubed, and let's go ahead and just look at the original table. Now when you're doing your homework, you don't need to go ahead and inspect the original XY table thoroughly like this. You don't have to do what I'm doing. It's just so that you can get a visual of what I'm actually talking about. Now the original XY table goes from -2 all the way up to +2. And this is the table that you memorize. And that you very quickly graph for the parent function. Now what the, let's start with the quarter on the outside. What the quarter on the outside does, that 1/4, is it is going to vertically compress your function by 1/4. It's going to change the y values by 1/4. They're actually going to be 1/4 what they originally were. So the 1/4 is going to affect your y values. So 1/4 times -8 is going to be -2, and 1/4 times -1 is going to be -1/4, and then that's 0, +1/4, and then 1/4 times 8 is going to be +2, and that's how your graph is going to change. All of the old y values that you would normally use are now shrunk down by 1/4. Okay, you take those original values and you quarter them. And so you won't be using this anymore to graph your new function. And then your x values are also going to be affected, and they're going to be affected by the inside number. And it's going to be the opposite of what you think it should be doing. It's not going to take all of your x values and times them by 2. It's actually going to divide all of your x values by 2. It's going to cut them in half. It's going to half them. So if I look at this 2 times x, it's really going to take all of your x values and half them. Whatever your x was, it's going to split those x's in half. It's opposite of what you think that it should be doing. So then my original x value was -2, but now it's going to be cut in half. And then just following through, half of -1 is -1/2, then we have 0. Half of 1 is a half, half of 2 is 1, and everybody's just cut in half. Now, normally I do not go ahead and just draw all this out. This is just for a visual so that you can connect these numbers with what is actually happening as we graph using transformations. Usually I'm kind of just doing this in my head while I am graphing and making those changes off the original table as I go and graph each point. Now there's one more thing that we have to take in consideration, and that's this guy right here, and that is going to change your y values. It's going to make them opposite of what they normally are, and that's going to reflect over the x-axis. So instead of going down 2 for that first point, you're going to end up going up 2, which would be a reflection over the x-axis. So it pretty much makes your graph look upside down. And instead of going down a quarter, you'd go up a quarter. Instead of going up a quarter, you go down a quarter. Instead of going up 2, you're going to go down 2 at that point. All of these values, because of that negative, are going to be affected. And I just kind of take care of that as I go. So let's go ahead and graph the original function and see what it looks like. Normally, if I needed any help in doing this, I would not put in a table over here. I would just go ahead and graph the original very, very lightly. And I know really, really quickly it's over 1, up 1, over 2, up 8, back 1, down 1, back 2, down 8. And that's what I'm going to be looking at when I graph the real function that we're working with. That's what my brain is thinking of. I don't literally write the table out. Okay, so we are going to be moving to the right 2 units. So I'm going to move over to the right, and this is going to be the real answer to this problem. We are going to be using that giant dot I just put in as my new origin. We're just moving the original XY axis over 2 units. There's no up or down shift in this problem. And you do not have to draw on the dashed lines. I'm only doing that for the example. Sometimes I do it for an answer key and just do it really lightly. Sometimes I don't do it at all, it just depends. And you don't need to make your origin dot gigantic like this. I only did it so you could see it very well. All right, so now I ignore all the old numbers that are on my original XY table, and I just work over here on the new red one and just treat it as though it was the real origin or the original origin. Okay, so I'm going to try not to look over here because I don't really use that table at all, and I'm just going to keep my eyes over on my graph and also looking up at my function. Now normally I go over 1, up 1, but I see that my x's need to be halved and my y's need to be quartered. So instead of going over 1 to the right, I'm going to go over half as much, and instead of going up 1, I'm going to go up just a quarter as much. Now also I have to remember that I have this reflection. So not only do I have to change my up and overness, but I also have to go in the other direction. So instead of going up, I need to go down. So instead of going over 1, I am going to go over a half. And instead of going up 1, I'm going to move a quarter of that, but I'm going to go in the downward direction. And my eyes have not even looked at this graph over here. Okay, and then that's the first point. Now I'm going to go ahead and do my second point. Instead of going over 2, I need to go over half as much. So I'm going to go over 1 to the right. And instead of going up 8, I need to go a quarter as much, which would be up 2. But instead of going up, let's reflect and go down 2. And once you get those 2 first ordered pairs done on this graph besides the 0, 0, then it's like really easy because you can just use some symmetry to graph the rest of it. So instead of going left 1, I'm going left a half. Instead of going up 1, I'm going to go up a quarter. Actually, normally I would go down, but we are reflecting. And then instead of going left 2, I'm going to go left 1. And instead of going up to 8, I'm going to go a quarter as much, and that's going to be 2. And I'm kind of throwing in that reflecting right away as I say up. And then there's my graph. That's a really bad graph. Let's see if I can do this better. There's the bottom piece, and then there's the top. All right, that wasn't that bad. And then the blue is just the original function. That's what I'm usually thinking about, those ordered pairs and picturing the graph itself. I don't look at the real table. I don't write it down on the side of my paper. That's kind of like overwhelming over here, but to even look at. But let's go ahead and check those ordered pairs. I never really showed in my table, by the way, the actual reflection on Y, but here's the reflection on Y. This would be making all your Y's negative, which is that little minus sign out front. This would be 2, this would be a quarter, this would be 0, negative a quarter, and down 2. There's the actual reflection. So if you want to go super crazy on the table, then your final X and Y's that I have in my new graph come from that. I would be negative 1, comma 2, and there it is. I would be negative a half, comma a quarter, and negative half a quarter. And then I would have 0, 0. That's an easy one. And then we have 1 half, negative a quarter. Let's check if we have that graphed. Over a half, down a quarter. And then finally 1, negative 2, over 1, down 2. And keeping in mind that this is using our new fake percent XY axis with these ordered pairs right here, not off of the original. So back 1 from my new origin, up 2, back a half, up a quarter, over a half, down a quarter, and over 1, down 2.